In this video, we have a short overview of logarithms, look at some basic problems. Let's review the main definition. We have the log of x to base b equals to L, implies that x has to equal to b to the L. So whatever you're taking the log of here, that has to equal to this base taken to that power. Notice L is an exponent. That's what a logarithm is. It's an exponent. And this goes both ways. We can go from log to exponential form to log form. Understood that the base has to be positive. X has to be positive. Can't take the log of a negative number or 0. And the base cannot equal to 1. So we express each of the following to an equivalent logarithmic form. So in other words, they give it to you in this format. It's given like that. So we want the log form. So that tells me I have to have a log over here. And I have to have a base for that log. What's the base going to be? Notice here b to the L, and over here the base for the log is b. So this would tell me that for this one, the first one, the base would have to be a. The exponent is the logarithm, which is L. So in this case, the exponent is 2. That would go over here on the right. The other number has to go here. So the log of 1.7 to base a is equal to 2. In the same way for number 2, we're looking for a log given the exponential form. You have a log, and notice the exponential form here, the base for the exponential is 5, so it has to correspond over here. The exponent is 3, that's the L in the definition, so this will go over here, and then the 125 goes here. The log of 125 to base 5 is equal to 3 because 125 is equal to 5 to the third. On the next one, let me write it over here. The log, and notice the base would be e, corresponding to the base of the exponential. The exponent is x, so that goes on the right, and the other number will be here. So it tells me that the log of 9 to base e means log of 9 to base e equal x means 9 has to equal to e to the x, which is of course what we have over here. Normally though, if it's base e, we use the ln notation. So we can write this as ln of 9 equal to x. That would be the solution for that one. And the next one, just basic properties of logs. Or on most of these you can use just the regular definition. So let's say the log of the square root of 7 to base 7 is equal to what? This is simply asking 7 to what power would give me this. If I write this in exponential form, you don't see it. You can say, well, this means that the square root of 7 would have to equal to 7 to what power? So how do I get a square root of 7? Well, this would have to be 1/2, right? To get the square root. So that would be 1/2. And the next one, the log of 9 to base 1/3 is equal to what number? That's simply asking 1/3 to what power would give me 9. Well, 1/3 squared would be 1/9, but I want to get 9. Well, the only way I can do that is instead of a 2, use the properties of negative exponents and make this a -2. So that's the answer for that one. Now for this one again, we got 3. That 3 log of 49 to base 7. So for this part right here, we're asking log of 49 to base 7 is what? That's asking 7 to what number is 49? Well, 7 squared is 49, so this should be 2. 3 times 2 is 6. That's your answer. So we got 1/2 for number 4, -2 for number 5, and 6 for number 6. And the next one, find the domain of each function. So what are the permissible replacements for the x? That's the domain. Well, we know we can't have the log of a negative. We know we can't have the log of a 0. So because of the square on this x, we don't have to worry about negatives. Because if we put in a negative there, you square it, it'll come out positive, we're okay. The only thing we have to restrict is 0. And the only way we can get 0 here is if x is 0. So here, we simply say it's a set of all x such that x is not 0. Now for this one, g of x equals the square root of ln of x. Remember the base here is e. So if I were to look at the graph of this, the natural log of 1 to any base is 0. So I have an intercept right here. And then any graph with base larger than 1, it's going to go something like this. So on this side of 1, the graph is above the x-axis, so it's going to give me a positive number. But between 0 and 1, the graph is going to be a negative. I don't want this to be negative because it's under a radical. That means I take numbers to the right of 1. So for this one, it's a set of all x such that x is greater than or equal to 1. Now for number 9, at 4 plus 3 natural log of 2x minus 5, the main concern is right here. This 2x minus 5 cannot be negative and cannot be 0. So we simply want this to be, whatever we plug in, we want 2x minus 5 to be greater than 0. So we just solve this inequality for x. Add 5 to both sides here. Add 2x greater than 5, adding 5 to both sides. And then divide by 2. We can divide by positive without changing the inequality sign. Domain for this one then will be the set of all x. And we're okay as long as we pick a number greater than 5/2. X is greater than 5/2. That's your solution. And for number 10, basic equation. Can't get any more basic than this. Using your definition, we know that this right here, 2x plus 1, has to equal to whatever the base is, in this case 2, taken to the number on the right, that's 3. So we subtract 1 from both sides to isolate that term with the x. This, of course, is 8 here. Subtract 1 from 8, we get 7. Divide by 2. And we get the solution. X 7/2. Now this last two are pretty basic. It's ln of e to the x. Remember the base for the ln is e. So if this is e and this is e, the left side simply reduces to x. X equal to 5. Number 12, the same thing pretty much. You have the log of 3, or the log of 3 to the x to base 3. Again, you have a base of 3 here and the base of here. These bases are the same. One of your properties, this is one way to do it. That simplifies to x. And the right side is -1. So the solution to this one, -1. Thanks for watching. We'll see you next time.